All right. We're going to take a look at what we call function notation today, okay? Function notation is one of those things that when you see it, you guys will recognize it, but it causes a lot of trouble, all right? Let's go to this screen right here, okay? If I ask you this, if I gave you this expression and said, what is y? And you see y equals 2x plus 3 if x equals 2. What would you do with this? And I think it was on the warm-up. If I gave you y equals 2x plus 3, and I said if x equals 2, what is y? You would substitute what? Substitute what number?
3.
What is x equal to?
1. 2.
X is equal.
6. 2. It's a 2.
X is equal to 2. So that is going to allow you to take this 2, and it's going to allow us to take it and substitute it for x. Okay? So we'll take the 2. We're going to plug it in for x. Plugging that 2 in for x, this is what we would be looking at. Y equals 2 times 2 plus 3. X equals 2 tells you to take 2, substitute it for x, which we have done, indicated by the parentheses. Guys, what's 2 times 2? 4. And what's 4 plus 3? 7.
That's it.
That's it. So if I gave you this expression and told you that x is equal to 2, and I said, hey, what is y? Y is 7. Okay? We put x in, we put 2 in for x. X is an input. Y is your output. 2 goes in, 7 comes out. It's like an input-output machine. Okay? This is more of a typical look of what we see. We're used to seeing x's and y's. All right? Everybody okay with this? Any questions about what just happened? Okay? We've got an equation, y equals 2x plus 3. Told you that x is equal to 2. We plugged the 2 in for x. 2 times 2 is 4. 4 plus 3 is 7. 2 goes in, 7 comes out. We're good with this. Okay. It's that problem right there. It's the same problem. All right. What you're seeing on this next screen. What you're seeing on this next screen is really the same equation. I have just written it with what they call function notation. Okay? And I'm sure, I think you guys look at that and you've probably seen this before. This causes some issues. Here's the way you read it. Okay? Right here on the left. I'm going to read that f of x equals 2x plus 3. F of x equals 2x plus 3. That's the way we read that. F of x equals 2x plus 3. This thing right here, that's what causes the issues. Okay? Now, what is function notation? Function notation is going to give you the name of a function. Okay? So, the name of the function is f. The name of the function is f. That's what that f is. The f is just a name. Okay? The x is what the function depends on. Okay? So the name of the function is f. The x is telling you what the function depends on. This function depends on whatever you put in here for x. Okay? And then the last piece to this, the function is 2x plus 3. Okay? So this is kind of the anatomy of this function written with function notation. F of x. F is the name of the function. X is telling you what it depends on. And then the 2x plus 3 is the actual function. That's kind of the main player in this thing. Okay? Any questions about that? F of x equals 2x plus 3. And for all intents and purposes, f of x really just means y. F of x really just means y. Okay? All right? Questions here? There you go. Somebody's clearing their mind. Okay. All right, so here we go. F of x equals 2x plus 3. F of x equals 2x plus 3. And this is the way you're going to see this written. F of x equals 2x plus 3. So the function's 2x plus 3. They've given it the name f. They have labeled it f. It depends on x. Now that portion that I just circled, f of 2. F of 2. That's how you read that. F of 2. What that is telling you to do, it is telling you to go to the function labeled f. And please put a 2 in for x. It's exactly what we did on the first screen. Go to the function labeled f, which is this function right here, and wherever you see an x, put a 2 in there. That 2 is going to go right there for x. That's all that's telling you to do. Please go to the function labeled f, or named f, put a 2 in for x. And so here's what it will look like. We're going to take 2, we're going to insert it for x as such. And again, I would highly encourage you, if you replace a variable with anything, put parentheses around it. The f did not turn into a 2. That is f of 2. F of 2. F of 2 is telling you, go to the function labeled f, and please put a 2 in wherever you see an x. That's what that's telling you to do. So we went to the f function, which is 2x plus 3. We inserted a 2 for x. What's 2 times 2?
4.
4. And what's 4 plus 3? 7. F of 2 is equal to 7. F of 2 is equal to 7. It's exactly what we did on the first screen, written with function notation, but it's telling you to do the same thing. This is what we need to become more comfortable looking at and interpreting and knowing what to do. Okay? F of 2 is just telling you, please go to the function labeled f, put a 2 in wherever you see an x, and tell me what it spits out. You put a 2 in, it spits out a 7. Okay? Any questions here? Okay. We'll give you a second. I would jot those down real quick. Jot those down. This is why we need to give these functions a name. What if they give us more than one function? What if they give us 2? What if they give us 3? What if they give us 5 functions? What if they give us all these functions? How do we know which one is which? They're going to give them a name. Okay? Now, as you're writing there, notice what we've got there on the left. We've got f of x equals x minus 2. That's the f function. We've got a function labeled g of x. g of x is equal to 3x minus 1. And we've also got a function labeled s. S of z is equal to negative 2z plus 4. So we've got three functions here. We're going to make them unique by their names. We've got an f function, a g function, and an s function. And again, the variable that's inside the parentheses is just telling you what the function depends on. What's coming out of the function depends on what goes into that variable. Okay? So f of x, g of x, and s of z, really those are just names of functions. Okay? Now, over on the right, this is what we're going to evaluate. This is what we need to go find a number for. So the first one is s of negative 2. Well, if it's s of negative 2, which function are they telling you to go to? Which one? Go to the s function. Go to the s function. Which one's the s function? This last one here, right? Negative 2z plus 4. So this s function right here is we're going to take this negative 2 and we're going to go to the s function and replace the z with it. We're going to replace z with negative 2. So right here it's going to be negative 2 times negative 2 plus 4. That's all it's telling you to do. This is really, really very simple. We kind of get caught up in what it looks like, though. It looks more difficult than what it is. Guys, what's negative 2 times negative 2?
4.
Positive 4. And what's 4 plus 4? 8. S of negative 2, S of negative 2 is 8. All that means is that when negative 2 went into the function, 8 came out of the function. The input is negative 2, the output positive 8. Are we okay with this? Everybody good with that? Any questions there? Go to the next one. Let's go to f of 3. F of 3. Which function are they telling us to go to? Go to the f function. Which one's the f function? The top one. That's right. Again, that's why they've got a name. Now we know where to go. So f of 3 tells me, going, look, please go to the function labeled f, which is the top one. Please take that 3 and put it in wherever you see an x. So we're going to take 3. We're going to replace that x with it. We're going to put it in parentheses. And it's just x minus 2. So all it's going to be is 3 minus 2, which is 1. So f of 3, if I go to the f function and I put a 3 into it, what comes out is a positive 1. X goes in, technically y comes out. Okay? Any questions there? Are we okay with that?
Sure.
Guys, it's plug and play is really all it is. Go to this last one. G of 4. Which function are they telling you to go to?
G.
Go to the G function. Which one's the G function? It's the second one. It's the one in the middle, right? So we get the G function. They want us to put a 4 into it. So we're going to take this 4 and we're going to go put it right there for x. Now that's 3 times x. So it's going to be 3 times 4 minus 1. 3 times 4 minus 1. What is 3 times 4? 12. And 12 minus 1? 11. So G of 4 is 11. I mean, it really is. Like I said, we've got to get past what this looks like. It looks more difficult because they're throwing all this algebra-looking stuff at us. We've got variables. We got f of x, s of z, okay, all that kind of stuff. Guys, they're just giving it a name, and they're telling you what that function depends on as far as the variable, okay? And like I said, for all intents and purposes, f of x is really just y. G of x is y. S of z is y. That's really all those are. But how do we know which function to go to? They've got to give them a name. In this case, it was f, g, and s. Okay? F, G, H are very common. F, G, and H are very common, but sometimes they will use other variables for the name and the variable that's involved. So, I mean, it varies a lot. Okay? Pretty simple deal, though. All right, any questions about what we did on this slide right here? We got it? We can do that? Okay. All right, so here's what should be in Canvas, okay? Listen carefully. We're going to do them all. I don't really care about the puzzle, okay? Do them all. I think it's, what is that? It's 12 problems. 12 problems. And it looks like you're evaluating each of those for one number. Okay? So it's just 12 problems. We just need the reps just to, this was the easiest thing I could find that I thought would be pretty easy and straightforward. Some of the other stuff I found, I want to start easy here. Okay? So we're going to do all of these. Okay? We will do them all. All right? I tell you what, let's do, now that I'm looking at this a little bit, negative n squared minus 3 and g of negative. Okay, here we go. 4/3 x minus 2. They want to evaluate for r of 2. Hey, take a look. Take a look up here real quick. Okay? There is one of those functions. One of those functions is g of n. G of n equals negative n squared minus 3. Negative n squared minus 3. They want you to evaluate g of negative 2. So they want us to go to the g function, which is that one. Let's put a negative 2 in wherever we see an n. Now be careful here. Notice what's in front of your n squared. What's in front of the n squared? Negative. A negative, okay? So again, I would highly encourage you, when you plug in this negative 2, here's what I would encourage you for it to look like on wherever you do the work, okay? Keep your negative, open parentheses, put the negative 2 in for n. Notice my squared is still there. And then minus 3. But I would do that, okay? You're going to need to keep up with your signs here, okay? What would you do first right here? Say again? Well, order of operations. What do you do first, exponents or multiplication? Exponents. Okay? This right here needs to get done first. That little negative sitting out front, which technically is a negative 1, that needs to wait. That is multiplication. Guys, we need to take care of that exponent. What is negative 2 squared? What is negative 2 times negative 2? 4. Positive 4. So really, here's what we have. Negative 2 squared is positive 4. It is still in the parentheses. There is still a negative sign out front. Okay? So now you would technically be allowed to multiply that negative 1 times 4. What's negative 1 times 4? Negative 4. So really, this becomes negative 4 minus 3. What is negative 4 minus 3? Negative 4 minus 3.
1.
If you're 4 feet underground and you go down 3 more feet, where are you?
Negative 7.
There you go. This comes out to be negative 7. Those darned integers. Those integer rules don't go away. Okay? So for some of these, guys, again, I would take the number, plug it in, and then you're using your order of operations to basically simplify this, to evaluate it. Okay? Pardon? Yeah, we'll do a fraction one. Okay? Is everybody okay with this?
Yes, sir.
Watch out for those exponents. Make sure that we're taking care of exponents first. Okay? Negatives. That one? Okay? All right, guys, we're going to do them all. It's 12 problems. That should be easily accomplished. 12 problems, get a few reps with it, get used to some of this function notation. Guys, it's really pretty simple. Again, like I've said a few times already, just got to get past what it looks like. Okay? When we see it, just need to know what we need to do. And 6. Okay, so let's look at this one. Let's do one that's a fraction. You've got r of x is equal to 4/3 x minus 2. And they want you to evaluate r of negative 6. Okay, so again, they want us to go to the r function, which is that one, obviously. I think that's obvious. And they want you to put a negative 6 in for x. Okay, now, again, just like we've been talking about, keep your 4/3, open parentheses, plug the negative 6 in for x, and then minus 2. Okay? Now, we have a fraction being multiplied to a non-fraction. Here's what I would recommend. Really, at any time, if you're ever multiplying a fraction to a non-fraction, I would make the non-fraction a fraction by placing it over 1. That way you're looking at basically 2 tops and 2 bottoms, 2 numerators, 2 denominators, okay? Because for some people this could get kind of messy, okay? So 4/3 times negative 6 over 1. Guys, when you multiply fractions together, it's across the top, across the bottom. It's across the top, across the bottom. What's 4 times negative 6? 4 times negative 6. Negative 24. And across the bottom, what's 3 times 1? 3. Across the top, across the bottom, negative 24 over 3. Still got our minus 2 sitting over there. What is negative 24 divided by 3? Negative 24 divided by 3. We've got a negative being divided by a positive. So it is negative 8. Negative 8. Negative 24 over 3 becomes negative 8. We simplify the fraction. So negative 24 over 3 becomes negative 8. We still have minus 2. What's negative 8 minus 2? Negative 8 minus 2. We're 8 feet underground. We go down 2 more feet.
Negative 10.
We are negative 10 feet underground. So r of negative 6, if we evaluate the r function for a value of negative 6, out comes negative 10. That would technically be our y value.
Negative 10 is the answer.
That's it. Okay? But if you ever get in a situation where you've got a fraction being multiplied to a non-fraction, make that non-fraction into a fraction. Place it over 1. That way you see 2 tops and 2 bottoms. Because I will have people that will take that -6 and they will multiply it to both numbers, and that is not the case. Trayshawn. Yep. Any questions here?